This is recording in progress. Yeah. Now, we want to discuss about three things today. We want discuss about uh, integral or integral by parts, yeah, by parts, and uh, then we want to talk about defining integral, the application of integrals. And for the application, we just talk about area of region between a curve. Yeah. Maybe we in integral we have many application. Today in this meeting, we only talk about application of integral in the area of region between curve. So we start with the integral by parts. In the integral by parts, we use this property. We know from the derivative that differentiation of two multiplication of two function. In this case, u and v. We know that from the rules in derivative say that u dv dx plus v du dx. And then we move one component in the right side. Then we have here, so we move second components to the another side. We have this one, yeah, this one. So we take integral both of this side. Yeah, we take the integral for both of this side. So here in the in the left side, mm, the same will be put here. And from the property of integral, uh, we have the u dv dx integral over x. Uh, it's look like we can cancel out here. So we have in the right side, in the left side will be integral u dv. For the side, for the right side, we have integral of d dx dx of uv dx. So also from the definition of antiderivative, we can cancel out this one with this integral. So we have uv. Of course, for the third, we have that integral v du dx over x. So we can cancel out dx. So we have integral u v du. Yeah, and so on. Yeah. So uh, it's make us have uh, in the left we have integral u dv, and in the side we have the first will be uv, and the second will be integral v du. So we have this formula, yeah, to find uh, integral by using the formula of integral by parts. The question is, we want to find the integral, but the formula say that we have this formula, and still we have another integral. So we are wondering why we still have integral here in the right. But the answer is by using the formula of integral by parts, we hope, yeah, we hope, and this is our goal. Uh, the integral in the right is easier than integral in the left. So integral of v du is easier easier than the integral of v du. Yeah, it's the idea. Uh, yeah, of course. So we want to solve the problem of integral in the left. Then we hope by using the integral by parts, we have the easier integral in the right. Yeah. So this is the idea. Yeah. This is the idea. Uh, to to make this get this idea or to make us have this condition, so we must choose correct u. Jadi we have choose u v and so sorry still in bahasa uh, and v and dv such that such that such that uh, v du fulfill this condition. Yeah, so this is the most important things we should do. We must choose the correct u and dv. Yeah, this is the okay. This is the symbol. The symbol should be integral of v du. Here the notations should be integral of u dv. So by using integral by parts, we must follow this step. We must choose right. We must choose u and also dv. So we must select dv such that can be easily to integrate. So because in the right dv here we must have a v. So we must integrate dv such that we can integrate v du. So we must select db such that it can be easily integrated. Okay. We have some suggestion how to uh, choose the right u. This is the suggestion. We call it in bahasa lipat, lipat, PET. Uh, this is the priority to choose you from the left to the right. If the integral contains logarithm, so please choose the logarithm become u. If uh, we don't have logarithm, so we can choose inverse of trigonometry. And we don't have inverse of trigonometry also. So the next one we can choose polynomial and so on. Yeah. So if we don't have the three previous, so we can choose exponential as the our function u. And the last, we can choose u as trigonometry. What is logarithm? Yeah, logarithm can be like this, ln x, for example, or log uh, 1, for example, and so on. Yeah. So any kind of function contains logarithm can be choose as priority uh, as u. And if I'm first trigonometry, this can be arc sine, arc sines, arc cosine, cosine, and so on. Yeah, some function uh, with the arc in the front of the function. And polynomials can be x squared, can be x cubed plus x, and so on. Yeah. So uh, you already know well what is polynomials. And what about exponential? Exponential can be uh, x power of e or x power of 2, and so on. And so on. Trigonometry, what kind of trigonometry? It can be cosine, or it can be sine x plus 1, so on. Yeah, uh, some function of the trigonometry. I hope you already know well also about the function of trigonometry. And look at this example. We have two integral, and the solution will use and the formula of integral by parts. Okay, we begin with this the first problem. We have here, uh, and then we have so here this is a polynomial. This is exponential. From the leap, we should use this is as u. Yeah, this is as u because polynomials in front of exponential. And after we choose u, the rest will be uh, as dv. Yeah, this is a dv. In the we need du, du, du. If we have u is equal to x, so du will be dx. And in the right also, we need v, dv, in this case, ex dx. So v is the integral of ex. We already know from the previous the integral of ex or x power of e is equal to ex. So this is ex. Next, the the formula of integral by parts, we must know these columns, this notation. U, U. must be uh, must be the we must derive u. Yeah, we must derive u. In this case, u is the function of x, and the derivation of this differentiation of this function is one. One. And what about dv? dv dv in our case, dv is ex. Actually, we must write ex dx, but uh, we we ignore dx. Just write as ex. In this case, we must integrate ex. We know from here, so the integral of ex till ex. Yeah. So we have two columns. The first column differentiation, and the second column is integral. Okay, let's we apply let's we use the formula of integral by parts. So this is must be uv, isn't it? uv. So this is u x, and the v after the integral of ex will be ex. Then minus the integral of v du, and the integral v du, v is ex, then du is 1. 1 in this case will it means that dx, yeah, because uh, this is uh, uh, we have 1 here. So in this case, du it means as dx. So we have this one dx, and we can look at that the integral in the right is easier than the integral in the left. So we have x power of e minus, and this is still ex, yeah, and we must write the last by plus by c. Okay. This is the uh, by using integral by parts. Next, we look at the second problem. We have here the polynomials, and here we have logarithm. So uh, we have the priority to choose the logarithm as u. The rest here, uh, accompanied by dx, we s- uh, we we can say this is dv, and logarithm ln of x is u. Okay, let's we write the columns again. Uh, u in this case ln, so we must derive them. The uh, derivation will be differentiation will be 1 over x, and then the 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 second column is uh, x square, the function of dv, and then we must integrate it. We have 1 over 3 x cube. Please remember, yeah. So the first column is about v, yeah. Sorry, u, and the differentiation will be du for in this case. Yeah, this is the first column. The second column is dv, and then integrate them. We have v. Yeah, this is the second column. Okay, let's apply the integral, the formula of integral by parts. So we have here as u log, yeah, log x. This is v, so we have 1 over 3 cube of the uh, u is ln x, and minus as this is v 1 over 3 x cube, and du is du is 1 over x, 1 over x dx. Okay, I will write it again for you. This is v, and this is u, and this is v, and this is dx, du. Okay. Uh, we have 1 over 3 x cube. Uh, Here we can uh, uh, cancel out 1x, and then we have 1 over 3 can be pulled out from the integral. So this is will be x square dx. Okay, this is the integrals in the right. So we need integral it. We have then 1 over 3 x cube ln x, and this is 1 over 3 times 1 over 3 over here. From the integral, we have 1 over 9 x cube, and the last must be add by c. So this is the example 10.1. Yes. Now we have already some exercise, and I, I will make it quick for you and look at how to solve it. Uh, in here, I write the solution of number one. This is u, uh, and this is v, isn't it? So we have learn 2x. The um, the differentiation of this function will be 1 1 over 2x, but we have chain rule. The differentiation of 2x must be 2. So we have du is 1 over x dx. And this is dv. dv is dx. In this case, we can write as 1. Yeah. Dx is equivalent the with 1. And integrate of this this function will be x. So we have the solution for number 1 is u times v. So we have x ln 2x minus the integral of x v as v x, and the du is 1 over x dx. So x can be cancelled out. So we have x ln 2x minus this is, yeah, integral of dx is x, and plus by c. And how about this one? Number two, we have then uh, this is u. polynomials, and the rest is dv. So we have here it's differentiation of x here, number 2, yeah. Differentiation of x is 1, and the things uh, we have cos x, and the integrand of cos x will be sine x, sine x. And so we have the by parts. Integral by parts will be x sine x minus uh, integral sine x dx. So we have x sine x minus this is will be the integral of sine x will be minus cosine will be cosine x uh, plus c. This is the result, yeah. Okay, number three. Number three, we have here also the long. This is the uh, SU. This SU, and the rest will be DP. So we have here ln uh, Z, and derivative of ln Z will be 1 over Z, and the dv is 1 over Z squared, and the integral of Z squared will be minus 1 over Z. Yeah. So we can multiply minus Z by Z, Z here, and the integral of minus 1 Z, 1 over Z, yeah, 1 over Z, and the du will be 1 over Z, 1 over Z dz. And we simplify it, minus 1 over Z ln Z minus minus plus, yeah, plus integration of 1 over Z squared dz. Okay, after we simplify it, we can count. We have minus 1 over Z ln Z, and this is we have minus 1 over Z plus C. Yeah. Okay, this is uh, the integral by parts of number 3. What about number 4? Number 4, we try to uh, make the column here. Uh, this is the SU, and the rest will be dB. And U here, U will be x squared, and the derivative of x squared will be 2x, and uh, x power of 3, x power of 3, the integrate of x power of 3 is uh, x power of 3 divided by ln 3. Okay, we We have a square of is, uh, 3, x power of 3 divided by ln 3 minus integration of x power of 3 divided by ln 3 and multiply by 2x, 2x dx. So in this case, we have we have another integral. So it means that we must apply, yeah, we must apply the uh, the integrals, integral values. For this case, number 4, we have something to do, something to do, uh, not by making integral by parts again, but we continue the table. We continue the column here. We continue the column and we do something uh, and we make it short. Yeah, we make the equation is shorter shorter than before. Yeah. So how to do that? Uh, the the first column, uh, as we know before, we must derive them. So x square, derivative of x square or differentiation of x square become 2x. And then we continue to derive them. So we have 2. 2. And then again, we we continue the derivative of the first column until we find 0. Yeah, this is the requirement here. 2x, the derivative of 2x become derivative of x squared is 2x, derivative of 2x is 2, and derivative of 2 is 0. So this technique can be applied. In the another column, x power of 3 become x power of 3 divided by log 3. So integrate again, we have x power of 3, x power of 3 divided by ln 3 square. And then again, we integrate them, become x power of 3 divided by ln 3 cube. So the integral by parts can be applied by using this technique. We multiply this diagonal and uh, give the sign plus here. And this is we multiply this diagonal. We give sign minus here, and then uh, we give uh, this diagonal, and we uh, we give plus sign it. So um, we have plus minus plus. If there is another diagonal, must be the next must be minus and so on. Yeah. So we have this alternating sign. Okay. And how to apply it? It is easy. Just write the multiplication. So we have x squared times by 3x multiply divide by ln 3, then minus 2x times x power of 3 divide by ln 3 square. Uh, the the third component we have 2 times x power of 3 divided by ln 3 cube, and the last must be add by c. This is uh, the approximation or the approaching to solve the problem by using columns. Yeah. So we don't need to do integral by parts, integral by parts, multiply integral by parts. We just need write these columns. Yeah, the requirement is as long as in the first column, uh, the derivation of in this first column uh, can be become 0. Okay, so what about this one? So please apply this condition. In this condition, we have here uh, u is ln square y, and number 5, yeah, number 5. This is number 4, and we learn square learn y square, and this is the rest is y square as the d dv, and we derive here we have two learn here, and for here we have we have to integrate of y square will be uh, 1 over 3 y cube, y cube. Okay. Uh, in this case, can do, uh, we can apply the formula like in number 4. Yeah, because we look at this first column, the derivative is not tend to be 0. So we can apply one by one after we apply one integral by parts. So we analyze and we continue to do the next integral by parts. So we have here the first integral by parts for number 5. We have 1 over 3 y cube ln y square, and minus the integral of here to 1 over 3, yeah, it's the 1 over 3 y cube multiply by here the u 2 ln y divided by y dy. So we can uh, cancel out, become 2 here, and 2 minus 2 times 1 over 3 can be pulled out from the integral. So we have 1 over 3 y square y cube ln y square minus 2 over 3 integral y square y square ln y dy. Yeah, you can look at that. We have, we have the problem in the left, in the right, the integral of in the right, integral in the right is easier than the integral in the left. But we can apply the column like in number 4. So we must do manually the integral by parts in the last. Yeah. We do the integral by parts again. So I write here for you. This is equal to like this. I write again 1 over 3 y cube uh, y square uh, minus 2 over 3. Yeah. So in the last integral, we still use integral by parts. So we have ln y as u, and the derivative will be 1 over y, and the dv will be y square, and the integration of the y square will be 1 over 3 y cube. Okay, so by using the integral by parts in the last, we have that this one 1 over 3 y cube ln y minus then 1 over 3 y cube multiply by 1 over y dy, yeah, as du, yeah. So this is can be cancelled out again. So we have 1 over 3 y cube ln y square minus we have multiplication of 2 over 3 times 1 over 3. We have 2 over 9 y cube ln y. Then we have plus, yeah, minus time minus become plus. And still we have 1, 2 over 9, the integral of y square dy. Yeah, this is the simplification uh, of the last equation. Then um, again, we still have one integral in the left. In the right, we have 1 over 3 y cube ln y square minus 2 over 9 y cube ln y, and the plus will be 1 2 over this is must be multiplied by 1 over 3 again. We have 2 over 27 y cube plus c. Okay, this is the last answer of number 5. Okay, this is the first discussion, the first topics uh, of our discussion today. We have already talked about integral by parts, yeah, integral by parts, and then we go to another topics, definite integral, yeah, definite integral. Okay, this is the second topics about definite integral. And what is definite integral? I jump into the formula. Yeah, I jump into the formula. Definite and integral. It means that the integral with the upper limit and lower limit. So in the previous, we have this notation, integral of fx dx. So this is called as uh, uh, indefinite, indefinite uh, indefinite integral, integral, and so this is definite, yeah, definite integral. So this is definite integral. Yeah, you can look at that without limit, upper and lower limit. We call the integral as indefinite integral, and with the uh, lower and upper limit, we say it as definite integral. Okay, so how to count it? How to calculate it? We use this. Uh, oh, something wrong, eh? Um, yeah, I, I will write for you. This is the uh, function. The function state must be continuous. We call it the first fundamental theorem of calculus. Fx should be continuous, and this is must be on the interval from A to B, and we can say that the uh, uh, the derivative of fx dx must be capital Fx plus C. After we know this antiderivative, so the definite uh, integral can be write like this. Yeah. So we evaluate the antiderivative here. Yeah, we evaluate antiderivative here by using P, and then we also evaluate the antiderivative by using uh, lower limit. Or sometimes in some books say make this symbol for here. This is from A to B. Yeah. Or sometimes another symbol say that uh, uh, this is fx x from A to x from B. Yeah. Yeah, this is the definite how to count definite integer. So if you get the integral, the complex integral, please separate uh, the your 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 thing. The first is uh, finding the derivative. Maybe in the separate in the another space in and so the second take the antiderivative and evaluate them uh, using B. So uh, you can do it separate. In the easy integral, for example, here 1, 2, x. For example, we have x dx because the integral is easy, so you can write it uh, directly. Uh, 1 over 2 x x squared evaluate to the 1 and 2. So this is 1 over 2 2 squared minus 1 over 2 1 squared. Yeah. So this is how to apply this formula. Okay. Because of the notation is not too complete, uh, maybe this can be happen in the Microsoft Edge. Yeah. I open this slide by using Microsoft Edge, and some function have a problem to display. So uh, please ignore it because it is not too important than others. So we can continue to the next slide. Here some properties of definite integral. Here. This is say that the integral, definite integral for the same limits, the result will be zero, and we can change the position of lower to the upper to the lower, but the result differ on minus sign. And this is we can we can we can get the addition of integral in in the the requirement is C is in the middle of A and B. So might be for like this. This is A in the right, in the left, B in the right. So C in the middle of them, or somewhere in the between A and B. So we the integral from A to B is equal to the integral from A to C and plus by integral C to B. Yeah, this is uh, the interpretation of number three. And yes, this is some properties of definite integral. We can refer it again in the future if we need to look at this property. Okay, so this is the example of definite integral. Uh, we can apply the properties. The properties say that we can separate this integral become two integrals, or integral of x squared dx from 0 to 2 minus the integral of 4 dx from 0 to 2. I make it detail in the first for you. The for the next, you can skip some step to make you efficient to write. Yeah. So this is 0 to x square dx minus, I have some disturbing notation of a WhatsApp group. Uh, I must I must change the setting of WhatsApp group. Uh, so this is disturbing me. Hmm. Notification. I will off the notification. Also, okay. Still, So, hmm, station. Okay, continue the presentation. So, uh, this is the integral. Uh, Here, uh, we have we have quite a complex integral. So we separate it. As I told you before, we separate it in the another space, maybe here. We find the indefinite integral 2 over uh, 2x minus 7 square dx. Yeah. So we can pull out 2 from the integral dx divided by 2x minus 7 square, 7 square. So using a little, a little, using a little substitution here, we have that u is equal to 2x minus 7 and du is 2 dx, 2 dx. So dx is, oh sorry, we already have 2 here. So we have that this is will be du divided by u square. And then the integral of this uh, the integration of this function will be minus 1 over u plus 7, oh sorry, plus c. And then we replace u by 2x minus 7. We have minus 1 over 2x minus 7. Now, uh, this is uh, can be replaced, can be put as the uh, capital X antiderivative of this function. So we have minus 1 over 2x minus 7. And we went from 4 to 6. We if 6 can be substituted to this here. We have minus 1 over 2 6 minus 7. And then we have minus, and again minus 1 over 2 times 4 minus 7. Okay, then we have minus 1 over 5 here. 12 minus 7 will be 5. Minus minus become plus. 1 over 8 minus 7. We will have 1. And then we have our 4 over 5. Yeah. So this is how to use integral by parts. We uh, can use directly like this, yeah, like this one. Okay, I must complete it, yeah. Uh, x squared, this is integral of 4 dx from 0 to 2. I make it in the top. This is will be 1 over 3 x cube minus 4x, and we evaluate them from 0 to 2. And so here we have evaluate 2 to the integration. We have 1 over 3 uh, to cube minus 4 times 2, and this is 0, should be 0, yeah, should be 0 because evaluation of 0 to this function will be 0, so we have 0 here, and then we can count it. This is uh, over 3 minus 8, and we have what we have here, minus maybe minus 16, yeah, minus 16 over 3. So this is the result of number 1, and this is the result of number 2. Yeah. Uh, this is the result, and this is the result. Okay, so the exercise can be done by yourself. I just make some tools for you. Uh, this is the irrational function. You can make it become power, or power, or power of function to make easy for you to compute it. So this is integral from 1 to 4, 5 y, 3 over 2 power of y, 3 over 2 power of y, plus 3 a half power of y, a half power of y. So I hope you can but you can do the integration easily. This is 5, yeah, 5 times. The integration will be 1 over 5, 1 over 5 over 2, yeah. So we have 2 over 5, y, 5 over 2 power of y, and then this is can be cancelled out, plus this is 3, and also 1 over 3 over 2, so we have 2 over 3, y 3 over 2, plus c. So again, we have the result is, so this is must be, sorry, we don't write plus c here. So this is must be from 0 to 2. 1 to 4, sorry, 1 to 4. So we have 2y, 5 over 2 power of y, plus 2, 3, 3 over 2 power of y, convert to 1 to 4. So we have 4. 4 in this case, we know that 4 is equal to 2 power of 2. So we, we have here uh, 2. So we have here 5 power of 2. So we can cancel out again. We have this is should be 5 power of 2. And we know this is 32, yeah. So this is 2 times 32. And again, also from here, we have 2, 3 power of 2. So we get here minus, substitute 1 to this function will be 2 plus 2. So we can count it, what we have here, 64, uh, 16, we have 80, 80 minus 4, we have 76. Yeah. This is 76. Okay, let's do it for the rest of exercise number 2 and number 3. Please do it by yourself. Uh, if you have some problem, you can separate it. Yeah. For example, in number 2, please find first 3 divided by x squared plus 2, 3x plus 2. Yeah. The x. So please find the indefinite integral. And then after you get the antiderivative, you can evaluate the antiderivative from 0 to 1. And also for here, please find the formula of integral cos sine x dx here. So you can get from the table maybe, or use software if you like, but in the class, in the examination, uh, you cannot use software. Yeah. So please evaluate the the antiderivative from 0 to 1. Okay, it's quite quick, yeah, and I will make it slow for you to make you understand well what we talk about in this meeting. I review in in this point. Now we already talk about integral by parts, and then we also talk about definite integral. So we already talked about two things here and here. Now we want to talk about number 3, application of integral in the area of a region between both. Uh, it is raining this in my house, so I hope you have good condition in your own house. Uh, okay, after we know the definite integral, we can apply the integral. Uh, I I write it for you. This is uh, fx, yeah, uh, the function of x. This is x-axis. This is line x is equal to a, and this is line is equal to b. And we have the illustration like this. We have function y is equal to fx, and this is x-axis. This is y-axis, yeah, y-axis, and this is line of x is equal to a, and this is the line x is equal to b. So this is the region we want to get the area. Okay, so uh, hmm, what we have here. Okay, I uh, make a decision to write down the function. This is y is equal to x squared from 0 to x. So the area, we must know the area. Yeah. Uh, uh, at least we can write. down the sketch of area to make us sure or give us the chance to check whether the solution is correct or not. So this is, for example, we have the formula, the proof of y is equal to x squared. So this is, for example, uh, x is equal to 3 and this is x is equal to 0. So we have the area like this. Okay, so this area can be calculated by using the integral. The integral say that the function will be fx here, so will be x squared, and then we integral over x, and this is our lower limit, yeah, 0, and this is the upper limit. This is 3. So we have that the area will be 1 over 3 x cube, and we evaluate them from 0 to 1. And we already have that substitute 1 to this function will be 1 over 3, and substitute 0 to this function will be 0. So the result will be 1 over 3. Okay, this is the illustration. If we have two curve, yeah, two curve. This is the first curve, and this is the second curve, and we have the area between these curves like this. So this area can be calculated by using uh, this formula. So this is the top, yeah, the top upper curve, and this is the below or lower curve, yeah, lower curve. So this is the formula to find the area of region between curve y is equal to fx and y is equal to gx. Okay, sometimes our regions can be easily to count by using y-axis. So this is y-axis. So we have the upper 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 function. uh, yeah. Before we say that this is upper. Now we say that this is what we call uh, right right apa, lebih ke kanan. Uh, yeah. Uh, right right in the right, yeah. The function in the right and minus by the function in the left. Left. So respect to x, the function must be uh, top and down. Yeah, we must upper and lower. But for the y, so we have right. This is right, yeah, right, and this is left. So we must know the context, yeah. And then for the integration with respect to y, the derivative must be using y variable, and the function should be in y variable also. So this is the uh, horizontal line. Y is equal to c, and d is horizontal line. Y is equal to d. So this is the formula uh, of counting the area of region with between fx, x is equal to fy, and x is equal to gy. Okay, this is the area. We can count it uh, by using this is the upper uh, function. This is the lower function. So we have the formula should be A is equal to yeah, this is the vertical line in the left, and this is the vertical line in the in the right. How to get this boundary, this limit? Uh, we look at this is the intersection between two curves, so we can equalize them. Y here and is equal to fx here. So this is 2 minus x squared. And move to the right, move to the left, we have x squared plus x minus 2 is equal to 0. And factor out them, we do factorization. We have what we have here. This is equal to 0. This is x plus 2. And this is x minus 1. X minus 1. So the solution is x is equal to minus 2 and 1. So we have this is uh, the lower limit and this is the upper limit. So we have here 1 to 2 and our function uh, the the top is 2 minus x squared and subtract by minus x. Minus x is the lower function. So this is uh, the area. And 1 to 2, yeah, simplify it by 2 minus x squared. Okay, this is easy to find the integral. Uh, so we have that 2x minus 1 over 2x squared minus 1 over 3 x cubed. We evaluate from 1 to from minus 2, yeah, sorry. This is must be a mistake. Minus 2 from 1, minus 2 from 1. This is also minus 2 from sorry, minus from minus 2 to 1, yeah, from minus 2 to 1. I will make it clear for you. I will make it minus 2 from, from minus 2 to 1, and this is from minus 2 to. Okay, please evaluate this equation. 2 minus of half minus 1 over 3 minus 2 become minus 4 uh, minus uh, minus 2 plus uh, x over 2. And please uh, start there. Okay, look at uh, this problem now. We have the area enclosed by curve x is equal to y plus 1 and x is equal to 3 minus y squared. So we can uh, write separately, then we join them to get the area. X is equal to y plus 1, substitute y by 0, we have x is equal to 1 here. Then now y is equal to 1, y is equal to 0, so x is equal to 0, y is equal to minus 1. So this is minus 1. So we have the line like this. And this is can be x y square. Yeah, we know that this is x is x is equal to y square. This is x. This is y, and minus will be like this one. This is one, and then we get 3. So we have this, yeah, then we have this program. Okay, now we combine them in one graph. So yeah, we have like this one maybe, and then we we write this proof is is equal to minus y square. This is x is equal to y plus 1. So in this case, we want to integrate respect to y, yeah, respect to y. So we need to find the value of because the area is like this. So we want to find this value, and as we know from the previous, we can find the intersection by equalize to this function. We have y plus 1 is equal to 3 minus y squared, and move to the right. Move to the left, we have y squared plus y minus 2 is equal to 0. And we have y plus 2, and this is y minus 1. Yeah, I think it is the same with the previous example. Y is equal to minus 2 and 1. So this is minus 2 and this is 1. And we get the uh, area of this region is minus 2 to 1. And the right, the right is 3 minus y squared, uh, subtract by the left, yeah, y plus 1. This is respect to y. Okay, we continue. This is will be minus y squared minus y plus 2. And I think this is the same result as previous. We also have this integral, the different different they are different of the variable. Yeah. The previous have the variable x, and this example have variable y. Okay, this is the last slide for this meeting. You can count the area, and please be remember that you have two formula respect to x. The area will be AB uh, fx minus dx, and respect to y, It means that the area will be CD fx, fx, fx minus g. So this is uh, the formula to get the area of two curves. Okay, look at this also. We have this is, and this is x is equal to y. I think this is the same what we have in the example. So uh, is the solution is what we have example 4, yeah, 4. Oh, we don't uh, we don't write the explicit, yeah, of the result. So this is look like what happened in the example. Please do or read the example in the above. Okay, this is number 3. You must maybe you must write three linear equation. So maybe the area is in the intersection of the three equations. And also this one might be like this. Yeah, and this is the x-axis. This is y is equal to 4x minus x squared, and this is the region. Yeah, you can find the region will be uh, yeah, this is should be 4, yeah, will be equal to 4. This is will be 4 here, and the function will be for x minus x squared dx. So this is the area of number 3. Please do it do the detail by yourself. And if you find difficulties to solve the problem, you can ask the assistant, or you can ask me how to solve the problem. Okay, that's all the presentation of meeting 10 today. And thank you very much for your nice attention, Priscilla, Aaron, and Jerry. And see you in the next Monday. And uh, good morning and bye bye.
Thank you, sir.
Thank you.
Thank you, sir.